Thanks for joining. This webinar is about passive considerations in facade design and the effects of energy performance on a building. So it's one learning unit, one HSW learning unit under the AIA Continuing Education course. Simon Whelan is my name. I'm with Fenestra Pro. We're the course provider. And we're also a software vendor and development company in Ireland, in Dublin, Ireland. And I'll talk a little bit about that now in a few minutes. But as part of this course, we're going to look at some of the considerations around facade design at different design stages, looking from early conceptual through, schematic detail and construction documentation, and allowing architects to get a better understanding of the implications of their design decisions. Well, architects, building designers, engineers, anyone in that AE space really. What we're going to talk about is some of the effects of passive characteristics, particularly solar, thermal, and daylighting performances, and how these considerations can be managed and optimized through decisions looking particularly at the geometry and the materiality of the envelope and of the facade. So the learning objectives is we'll take a quick look at looking at end uses of energy consumption that are very much influenced and affected by the facade and how they relate to overall building energy performance. We're going to talk about building information modeling tools for a couple of minutes, including Revit and particularly Fenestra Pro, and how they can meet project design stage requirements around facade performance and envelope design and stuff like that. We're going to look at a couple of solutions, particularly, as I said, between the geometry and the materiality of the facade, and how we can, use something like Fenestra Pro to optimize our passive design strategies and some of these decisions that we're making at different design stages of your building envelope and what stage these decisions are best made. And then we're going to take a couple of minutes looking at some case studies of different projects in different places at different stages. So, as I said, conceptual, schematic, DD, CD, and just kind of talk about, early stage, high level decisions, late stage, very detailed decisions, and some of the detail around that. So, briefly going to talk about myself, who we are and why we're doing what we're doing. Building energy use, the impact of the facade on energy performance and passive considerations of the facade, and why this is so important, and like looking at it in the context of whole, building energy use and global energy use and things like that. We're going to talk about some design stages, as I said, and where, for example, we can use something like Fenestra Pro to look at your envelope, conceptual, SD, DD, etc. And then case studies, and we'll have a couple of minutes for Q&A. If you do have any questions as well, feel free to drop it in the chat box in Teams. We're testing out Teams as part of a webinar. We're not 100% sure, but I'm sure it'll be fine for our purposes today. I'm guessing that you've already submitted your AIA member number. If not, one of us will reach out to you, or please feel free to drop it in the chat box, or we can follow up, and there's no problem about getting units and course completion document or whatever that looks like to you after the course. So look, I introduced myself kind of briefly. I'm one of the founders of Fenestra Pro. So we're, as I said, a software development company. We're based in Ireland. I'm an architect by profession. Myself and my co-founder, we spent a number of years in architectural practice, and particularly around the technical design of buildings, looking at building performance and energy performance. Particularly, we did a lot of research and lecturing in those areas. I specialized in environmental design. My co-founder Dave did leaned into facade engineering, and I suppose that's where the concept of Fenestra Pro came from, that overlap between the facade and the energy performance of your building and how these things are, intricately linked. And we very much at Fenestra Pro have a mission, or, a reason for being around streamlining the facade design workflow, while always considering the environmental performance of your building, and that being brought to the fore as part of your design activities. We very much believe that designers should be empowered around these things, and have the kind of tools to deliver energy efficient buildings from these, very early stage right through the process to late stage, and firmly believe that energy performance should be as big a parameter as cost or aesthetic design, or some of the big things that we take into account as part of a building design project. So I suppose a number of years ago, when we were in practice, we very much felt that there was a requirement for a tool that could give designers an understanding of these implications of their design decisions of the facade. So things like window to wall ratio, where our glazing is situated in terms of orientation, uh, shading, how is that going to affect things? The spec of the glass, how is that going to affect things? But all of these things are the energy performance of your building. So the heat gains, daylighting, thermal performance, these passive considerations, I suppose, that we're very much trying to manage from an early stage. But when we lock in our design decisions, they get very difficult to change. Um, and these are things that can have huge impacts on the energy performance of a building. So if we talk about the importance of a facade for a couple of minutes, I mean, there's the obvious things that we know as designers that, look, it forms the architectural response. It's the skin of the building. It's it's what the layman or woman will see. It's what, like, bystanders, or it fits into the character of the environment, and it's the opportunity to create the architecture of a building, right?
Simon,
However,
will you be recording this that we could watch it later, play it back later with our colleagues?
there is a recording, yes, and is that Andrew, I believe. Hi, Andrew, good to
It
hear
is.
from you.
Hey, good
Yeah, we
afternoon,
can.
Simon.
Yeah, we can share this with you after the fact, no problem.
Thank you.
So yeah, really importantly, I suppose our envelope is the moderator between the internal and external environments, and what that brings, I suppose, is some of those basic requirements such as security and weathering, but really, and more, I'm sure, but really importantly, energy performance, right? The envelope and the facade is one of the biggest um, influencers on the energy performance of the building. We'll just talk about that, really quickly. If we take a typical building, right, there's a very nominal office building, and we look at the different energy uses of that building, we can see that things like heating, or in other words, heat loss, accounting for heat loss, accounts for 12% of the energy of a building. So we lose 2% through our walls, 2% through our floors, etc., the opaque elements, but crucially, quite a lot, 6% through the glazed elements of the building. We're using 19% of a typical building's energy use on lighting, on artificial lighting, or, to put it another way, the lack of natural daylighting, right? We're always going to need artificial lighting, but if we optimize and we maximize the use of natural daylighting throughout the day and throughout the year, we can certainly reduce that quite significantly. And then lastly, and quite significantly, ventilation and cooling accounts for 26% of the building's energy use. So we're looking at cooling and mechanical ventilation. So, like, these active systems are costing more from an energy point of view than anything else, and I believe that cooling costs more than heating. So being able to manage those, understand them, design for them, and manage them is crucial in the design of a kind of an efficient building. So all of these three things together is about 57%. So well over half of the building's energy use is directly influenced by the facade. Now, obviously, this is going to be very dictated by the location of your building, the typology of your building, the building's use, all of these kind of things. But just typically speaking, on this kind of nominal office building, 57%, over half of our building's energy use um, is directly influenced by our facade. So if we take this, and this is very loose science, don't get me wrong, this isn't any deep research here, but it's just kind of to put a little bit of context around this. If we take and try and understand energy use globally, We know that manufacturing is about 32%, 29% for transportation, but we know that the built environment accounts for something like 39%, maybe 40% of our global end energy use. If we say commercial buildings are about half that, or about 19% in total, well, then accounting for half of the building's energy use being dictated or influenced by the facade, we could say, loosely, don't get me wrong, very loosely, we could say about 10% of global energy use is affected by the envelopes of our buildings. So I just put this out here to kind of give it, to try and sort of raise a bit of context about how important envelopes and facades are in energy use. And I think it's incumbent on us all as designers to really bear that in mind when we're thinking about the design of a building and the envelope on our facades. Because if we take those couple of considerations that I spoke about, and the heat loss through the fabric, and daylighting, through our glazed elements, and heat gains or the requirement for cooling, these are three things that are very often very difficult to optimize, right? They will very often work against each other. So the less glazing I have, the better the thermal performance of my skin, of my envelope is, but the poorer my daylighting. I go the other way and I put lots of glazing and I have much better daylighting in simple terms. Okay, forget about glare or anything like that, but much higher level of daylighting in my space. But I've got very high solar loads and heat gains to try and manage. In other words, higher cooling loads. So these three things are often pulling against each other, and they're difficult to optimize. They're difficult to understand how we can achieve them. And that's where Fenestra Pro comes in, I suppose. And being able to understand these things at a very early stage will give us, a better understanding of how to manage them, I suppose. Something really weird going on my screen. I don't know if you guys are seeing this blue, but that's a little thing that didn't happen in the dress rehearsal, right? But we'll crack on. But if we take the different design stages against time, right? So this is our version of this. I'm sure you guys might have heard of this McLeamy curve in the past. So it just looks at BIM, building information modeling, and the principles around it, I suppose. And if we take the impacts of our design decisions at different design stages over time, we can see that we have a very high ability to impact performance at early stage, at pre-design, at schematic, but that ability recedes as we move through the project, right? And that makes sense because we're getting more and more locked in on things like the orientation of the building, the form of the building, the programming, at which point we're like at construction docs and procurement, we're looking at window frames and mullions and hinges or whatever else. So we start very broadly and we drill in as the project progresses. On the flip side, the cost of the design changes is very low and increasing throughout the design process. So again, it makes perfect sense because at schematic design, it makes very little, it has very little cost for us to reorientate the building or to change the form of the building or to, move spaces around or whatever. But that cost of the change of that design increases as we move through the project, to the point that if you're issuing construction documentation or you're on site and you're trying to change the form of the building or the location of rooms or God help us, the orientation of the building, it's going to have huge cost implications, right? So really our ability to impact change occurs between the early conceptual stages and up to construction documentation, but that window is narrowing as we move through this process. So if we take a couple of different design stages and we look at things like at conceptual design, we'll be starting to look at things like orientation, solar heat gains, solar loads on different facades. They're the kind of things that we can do very quickly, very iteratively in Revit and using Fenestra Pro to kind of understand our shading, for example, understand what facades get very high heat gains, what impacts the surrounding and the urban environment will have. and we can start understanding different forms and the effects of glazing or window to wall ratio on those forms, up to and including code compliance. So, if I am choosing ASHRAE 90.1 zone, blah, 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 what impacts will they have, or what parameters will they drive on my form in terms of window to wall ratio, or in terms of prescriptive performances of different elements? And what might that do to some of my design decisions? So Fenestra Pro and Revit in the conceptual design environment very early can help you understand that. Doesn't usually look all this blue. Not sure what's going on there, but nonetheless, we'll crack on into schematic design. So same kind of thing. It's still, we might be massing, we might be very early conceptually, or we might be into more detailed Revit models, but we're again maybe starting to look at glazing configuration, where my glazing is. If I've got 40% window to wall ratio under ASHRAE 90.1, where is that glazing situated? Is it loads to the south? Is it somewhere in between east and west, very little to the north? And then what are the impacts of those design decisions? If I have lots of glazing to the south, I'm going to have very high heat gains. I'm going to have, the requirement for shading, or to start looking at different glazing specs, for example, frit, all of those kind of things. And again, Fenestra Pro can start giving you an understanding of these things. Very iteratively as well, we can start looking at different shading solutions. So we can drive it based on some of our parameters, for example, or we can drive it through the UI of Fenestra Pro to draw on our shading strategies and see the impact. Okay, I've reduced my heat gains and my cooling loads, but I've completely killed my daylight performance in the space. So that's what I mean when I'm talking about these things pulling against each other and being able to understand and optimize them as we're moving through the process. But crucially, very early, because these are when these decisions can have the biggest impacts on our energy performance of a building. Moving into DD now, we're definitely into more detailed drawings in Revit. Where like Revit models with more, let's say, traditional Revit families, material properties, detailed elements within it, and again, Fenestra Pro and Revit can really, read and leverage this information to give you an understanding of how they're going to perform. So we can leverage the geometry of your facade and the areas and the spaces within the building, but also the materiality, what type of glazing, what type of spandrel, and what type of frame, for example. So all of these things are giving us R values of our selected, or of our overall envelope, or our selected surfaces or facades. It's given us solar loads internally, and it's given us daylighting performance internally. And that goes in a hierarchy. So I can look at the whole building, or I can look at overall facades, or I can drill into individual spaces and surfaces. And every time I select something, my dashboards update, my charts update accordingly to give me an understanding of these things. But all of the materiality and some of those decisions that I'm making is written back to the Revit environment as well. So for example, that, Guardian SunGuard neutral 67 is being applied to my glass families with the appropriate VLT and solar heat gain coefficient and R values, etc. But I can start changing those selections. So Fenestra Pro has a really good database of real world products. Lots of PPG, Vitro Glass, Guardian Glass, Saint-Gobain in Europe, and and then also lots of generic glazing systems as well on IGUs. So we can very quickly start searching for an optimal glazing spec. We can dial in a VLT or a solar heat gain coefficient that I'm looking for, or a U value, and it filters down my list to show me what's achievable in a given region, or I can filter it by environmental product declaration, etc. Crucially, though, when I select one of those specs, I can apply it to my model. So again, it writes to your Revit family, and it applies the properties. Now, it doesn't import geometry like, BIM objects or something would. It's just applying the properties to the existing family in your Revit environment. So therefore, the R value will change, the solar loads in the spaces will change, the daylighting will change, etc., etc. And then construction docks, same kind of thing, but even more detailed, right? So we're getting quite detailed now. We're into a scenario where we've a panel with that's fully glazed, but we might have a shadow box behind, for example. So we need to start categorizing and understanding that a little bit better. That's not 95% glazed, as in like 95% window to wall ratio, because there's a big solid chunk here. So we can start categorizing these things and we'll know that this is solid. We can start selecting the type of glass, center pane U value, edge of frame value, categorizing the frame. So very quickly we've got a more appropriate window to wall ratio in terms of the opening, but also a very robust thermal performance of this panel, including all the different elements and all the different aspects to it. And then obviously we can export that to Excel or wherever else. And then so if we have a very detailed thermal performance of one panel, we have it for the whole envelope or that whole assembly or whatever that might be. So going back to that kind of my version of the Macalimi curve, it's early stage, high level decisions, window to wall ratio, outline shading strategies, things like that. Late stage construction documentation, we're into like frame, mullion, spandrel, the thermal performance of your glazing, the edge of frame value, all of that kind of more detailed information. So I'll just talk about a couple of those different things and show them in a better manner. So looking at early conceptual, could be schematic. These things are always a little bit gray area, I feel. But like we can very much consider the shading effects of surrounding buildings from the urban environment. So in other words, surrounding buildings, what kind of shading are they casting on my, I'll just go back in this little video. What kind of shading and shadowing are they casting on different facades, different orientations? So I can quantify that. So I can see facade 3 to the west here is shaded 23% of daylight hours in a year. If I drill into it, I'm looking at the different surfaces, from that facade. If I drill in again, I could be looking at different January, February, March, looking at it seasonally. So I can very much get the quantification of that shading, but I can also visualize it. So I can play through a short video, pause it, search for a date or a time. Looks a bit sloppy again. I'm not sure what's going on with all these colors and stuff like that, but or that might be just my screen. But you can very much see these things, so you can quantify it, which is really useful in terms of what's measurable is manageable, right? But you can also visualize it and see what that shading and overshadowing looks like. Glass to wall ratios, again, very early stage. We might have a simple conceptual mass whereby we might start dialing in a code. Now, Fenestra Pro as well, one of our new features, which actually I'm not showing here, will locate your building and suggest codes that are appropriate. So in other words, if the location of this project is set in Revit as Boston, let's just say, Fenestra Pro will look it up and say, well, Massachusetts has adopted, and I don't know if I'm right or not, but just for example, ASHRAE 90.1 2013, right? Boston is in zone 3, so it will offer you up the prescriptive performances, the window to wall ratios, and any other information around that particular code that might be relevant. So you immediately can start, I suppose, sanity checking some of your design decisions against that code, or you could accept it, right? So you could even, play around with the window to wall ratio. I've just applied 15%. It draws onto my model. I can play around with OR values, or I could just hit apply the code and it will apply the appropriate OR values for my roof, my floor, my walls, the U values for the glazing assembly, the window to wall ratio. So immediately I just have a very dynamic, very kind of prototyped understanding of different thermal performances of my envelope. But I've also very quickly drawn a form with 40% glazing on all my facades equally. From that, I can start seeing heat gains in the different spaces. So obviously my facades, the spaces to the facades to the south are going to be quite high. Facades to the north are going to be quite low. I can toggle between peaks and averages, for example. And I can start also seeing daylight performance or shading or whatever that might be, you know. I can also just select and drill into individual facades. So I select this one to the south. You know, again, like I said, quite high heat gains. I can start drawing on or dialing in some, let's just say I've changed the window to wall ratio. I've put 60% on here, so higher window to wall ratio. Now, it's still 40 for the entire building. I've just taken more of it and put it on the south. So it's kind of redistributing it, you know. We're going to get very high heat gains to the south then, toggling again between average and peaks. You can see here, I've got 60% window to wall ratio to the south, equal everywhere else. It used to be 40. It's gone down to 34.7 everywhere because I've, you know, reassigned it to the south. But I'm going to have high heat gains that I need to start managing, you know. So how do I do that? Let's move into kind of, you know, say the next stage. I can start drawing or driving shading solutions. So I can drag a slider, for example, and just start drawing a horizontal canopy. I can type it in a 3-foot canopy, or, you know, I could drag the slider and it draws itself as well, you know. So therefore I can see the impacts of reduce my cooling loads, but I've also reduced my daylighting. I'm looking at the overall facade here, but I can also get a little bit more granular and just look at these first floor spaces. Say it's a retail unit and a restaurant. I want a much deeper canopy because I have covered seating. I want glass to wall ratio of 95%. Whatever I want, I can, you know, I can get a little bit more granular, but always I can see the impacts of those things. And, you know, I've pretty much wiped out my daylighting in those first floor spaces now. So very quickly you can understand that and see that as part of your, you know, conceptual early schematic activities. Moving into a kind of a more detailed Revit model, we might start wanting to populate our facades. So we could, you know, draw windows or draw curtain walls using Revit and just use Fenestra Pro as an analysis tool. In other words, it updates every time you refresh it, and, you know, every new window or new wall that you've applied or new curtain wall that you've applied will be accounted for. Or you could drive it parametrically, I suppose, through Fenestra Pro. So I want to say 30% window to wall ratio, but I have a known window size of 1 meter by 2 meters. I could space them out equally. I could put in a spacing. I could change in an individual's office that I want, you know, floor, you know, a sill height at floor level. I can have wider in certain spaces or certain areas. So I can just keep drilling in and getting quite granular. But every time I make some of these decisions, it will preview it onto my model. Hasn't drawn anything. It's just previewed on, and I can see them just as polygons. When I'm happy with it, happy with that preview, I can apply it. So I'm committing now and I'm applying and I'm dropping in Revit window families onto my model. And it's just drawing with the appropriate geometry, size, spacing, sill heights, all of that kind of thing, but also crucially, a selected glass. So therefore, I'm going to see daylight in the space, heat gains in the space, thermal performance of your envelope, etc., etc. So I can do that with windows, but I can also do that with curtain walls. So same kind of concept, right? You know, I can drive it geometrically, but I can also drive it based on performance. So I could say I want a heat gain in that space, you know, a cooling load of 20 watts per square meters or 10 BTUs per square foot, and it's not to go over that. So Fenestra Pro will preview on the appropriate area of glazing. I could change the glass type, might get a little bit more glazing with a different solar heat gain coefficient. I could, you know, apply some shading, but all the while it's previewing and it's just giving me an understanding of what I'm going to achieve. And then I apply it and it drops in as a Revit curtain wall family, maxing out on that 10 BTUs per square foot cooling load in that space. And then obviously any other, you know, Revit curtain wall information that you've applied, the panel spec, the grids, all of that kind of info, you know. And when we do apply it, you don't see it here, but obviously my dashboards update, my charts update accordingly, and just very much real time and understanding of how we're achieving these things. Moving into DD, again, like I touched on earlier, much more detailed. Revit families, they have properties, lots of information going on here. So we need a better way of navigating it. We can kind of do little previews where we can select the different spaces and different surfaces that I'm looking at. We can select it by orientation. We can select it by the story. We could select it by just the number of the facade, or indeed we could rename those facades. So rather than facade 2, I can call that, Simon's facade or my key facade or whatever. But I can also create facade groups. So I want, key facades, and in that key facades group, I'll put in facade 2, 3, 4, 9, and 12, and then every time I select the group, everything will be selected. So when you do select something, my dashboard updates and I can see all of the different components within that facade or that surface, and I can change them, right? So I can affect change on my materiality. Touched on this earlier on. We can search through a pretty sizable product database based on performances. So based on a U value that I'm trying to achieve or a solar heat gain coefficient that I'm looking for. Lots of other tools there I can use as well. I can reach out to a Guardian, design manager or a Vitro. I can, request a Vitro sample or, all of that kind of information. Or I could just go straight to the website of that Vitro solar band to download the product spec, with all the information. And, there's lots of really good tie-ins around that kind of stuff. So there, a second ago, I was applying a spec of the glass, the IGU, based on properties. So I was looking for a U value, I was looking for a solar heat gain coefficient, but here I can also do it based on the performance in the space. So I want a heat gain or a cooling load of 25 watts per square meter or 10 BTUs per square foot. I want a daylight performance of an average of 4%. I want a U value of 1, whatever. And every time I dial in those filters, my product database updates to, filters down to show me these are the, units that will achieve that. There's that solar band 60. Go to the website, download the spec, apply it to my Revit model, properties drop into the family, and we keep going accordingly. And I know as a designer, that is going to achieve the performance that I needed to achieve, whether that be driven on the performance or by code or whatever else that we're trying to achieve. A little bit more on shading. I showed you some shading, simple shading analysis of a conceptual mass, but look, same inputs, same outputs on the more detailed models. Here's a more detailed model with, sort of a unitized system, and this panel, this current wall with the big shade, or a big, whatever that is, over it. We can analyze the shading of that. We can orbit around that model. We can, play through the year, identify a particular hour or day and what that might look like. But crucially, again, we have the data. So facade 3 to the west is shaded 40% of the year on average, or 40% of the year, throughout the year. But then looking at seasonally, January might be shaded 50%, but July is only shaded 25%. So you can, again, just get an understanding of the seasonality of some of your design decisions on these things. Shading will affect your heat gains. So if I've got big shading canopies or I've got a building across the street, I'll have a greater level of shading, but I'll have lower heat gains on, hitting that facade and penetrating that room. Shading will also affect your daylight and performance. So, again, it's just good to be able to understand and weigh these things up against each other. I touched on it there a while ago. What's measurable is manageable, and we're big believers in that kind of data-driven design stuff. You've got a sense looking at this that Fenestra Pro kicks out data and charts and graphs within the Revit environment, but it's also very robust and deep on our reporting platform. So even more information from your project. And when you log into the reporting platform, you can start manipulating some of that design data, creating your own charts and graphs, and I want a graph that shows me window to wall ratio by facade, but also I want to see percentage shading on that graph, or heat gains, or whatever that might be. I can see it as a graph. I can create a table, all of that kind of information. But we've also got all of your quantified areas, the materials, the properties of those materials, the specs, etc. And then moving into construction docs, right? So this is all very loose. I mean, you could use this much earlier in the project, but just to try and categorize it somewhat. We've also got some pretty cool tools around, like, look, our database is off the shelf IGUs, right? The Guardian products, Vitro products, for example, that are most used. But I could go to, for example, the Guardian Glass Analytics tool or the Vitro configurator. So I want a triple glaze unit that has this gas fill, this coating on surface 2, a frit on 3, whatever, all of the design data that I'm just creating my own triple glazed unit. That is calculating the U value, the solar heat gain coefficient, the VLT. From there, I can export that from Guardian Glass Analytics or from the Vitro Construct tool straight to Fenestra Pro. So this is my glass database. This is what I see when I log in. These are my customized glazing units. So Simon's example makeup, Fenestra Pro glass, default, whatever that might be. And then crucially, when I go back to Revit, they are there in my database, in my list of products. So in other words, this project here, I can apply Simon's example makeup that I've just created on the Guardian Glass configurator. I apply the U value to that glazing, the solar heat gain coefficient, the VLT, etc., etc. And it's just really good for customizing or bespoke sort of IGUs. I think this is just a repeat of what we kind of saw a few minutes ago there, but needless to say, the more detailed stages you're really getting into, or maybe a facade engineer, maybe you never touched this, getting into some of the weeds around your facade. So for example, glazing will have a center pane U value, but it will also have edge of panel values in accordance with NFRC, and that U value may not be the same, will not be the same. So using Fenestra Pro, you can categorize them, calculate that very quickly, export it to Excel, and have a very robust and accurate thermal performance of that entire assembly, including the center pane, edge of panel, whatever frames, mullions, shadow boxes, spandrels, etc., that are accounting for that entire panel. And we can really get into the weeds around it.